And then later, we will be discussing the considerations on the design and modeling and also the 3D printing of the part. So let me proceed with the presentation. First, let me define metal casting. It is a process where metal objects are created by pouring molten material into a mold and allowing it to solidify. So some of the common processes used in metal casting are sand casting, investment casting, die casting, and centrifugal casting. So each of them have different mechanisms, and each of them have different advantages. So pattern making, of course, if you want to cast something, you need a representation of the part that you want to make, and that is called a pattern. So patterns are used in the creation of molds, particularly in sand casting and investment casting. Patterns can be made from various materials such as ferrous metals, aluminum, plastic, wood, and even wax. So that's the one for investment casting. So traditionally, how we did patterns was we make it out of wood by carving wood or maybe cutting up different shapes and putting them together to make the shape, the final shape that we want to make. So this was how it was made back then, or until now. Actually, it's still being used. Now, the concept of additive manufacturing. Additive manufacturing is a process that deposits material layer by layer to build the desired part. So it's commonly known as 3D printing. It has a wide array of materials, including common plastics like polylactic acid, ABS, the plastic that you use for Lego, that's ABS, PET, and engineering plastics like PEEK. PEEK is being used as a substitute for aluminum because it can be equivalent to aluminum strength without the weight. Okay. Carbon fiber reinforced nylon, which is also very good for engineering purposes because it has carbon fiber reinforcements. It's also used for printing resins and ceramics. And now, with modern technologies, we can also already 3D print even metals. Metals like stainless steel, aluminum, tool steel. A lot of metals are now being developed for use in 3D printing for special purposes, and a lot of other things. Even food, concrete, clay is being 3D printed now. So, what are the uses of 3D printing? 3D printing is most ideal for rapid prototyping. I will be discussing on that later. It's also very good for uh, printing common plastic materials, the ones that are inexpensive, because of course one of the main things that if you want to make a prototype, especially if you're from a small business or even if you're a student, is the cost of making your product, your prototype. But with 3D printing, it allows you, because it's commonplace now, it allows you to make your parts in very inexpensive means, because you're able to just buy cheap plastic material, and as long as you have access to a 3D printer, which also comes cheap nowadays, yung plastic 3D printers, you can be able to make your prototype. And the additive nature of the process leads to less material usage. So we can compare it to machining. If you want to make something out of machining, you remove material from 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 a starting block. So that's the part that you remove, the chips is waste. You can recycle it, but it's of less value. Okay? So if you do additive manufacturing, you only use material for the shape or for the form of the part that you're going to make. So that's one of the advantages. And also it's able to do intricate geometries. This is one of the, I think, one of the most value adding things that additive manufacture can offer, because if you're familiar with machining techniques or casting techniques, you always have to consider the geometry of the part you're making. If you're doing casting, you always have to consider if the pattern of that part can be withdrawn out of the mold. So you have to think of the geometry. Same goes for machining, where you have to make sure that your cutting tool will have access to the features that you want to machine. So for example, if you have an internal surface that goes very deep and it might go through a uh, very tricky path going inside, it may be impossible or it may be very difficult. It might be possible, but it might be very, very expensive. For 3D printing, it removes that limitation because 3D printing, since it builds the part layer by layer, there's virtually no limitation on the shape or on the geometry of the part that you want to make. So it's also a useful tool in creating patterns for mold. So that's why we have this seminar right now, because one of the things that we found use for additive manufacturing is for it to be used as an alternative to traditional means of making patterns. And I will be discussing that in the next slides. So traditional and 3D printing pattern making. So that when it comes to design, the technical aspect of designing the patterns, they are similar actually. Because if you make a casting design, you still have to make sure that the flow of your material going into the part is controlled to reduce the turbulence. You also still have to make sure that the feeding of the metal from the risers is also effective. When it comes to that aspect, there's no difference while designing or in designing the 3D printed pattern and the wooden pattern or even the CNC machine pattern. Because when it comes to the mold, it's still going to have the same shape. The difference is how you're going to make it or the manufacturability of the patterns that you are going to make. And with that manufacturability comes the factor of costs and the factor of time that you might be able to save when you choose one over the other. Okay, so for traditional pattern making, it relies heavily on the skill and experience of a pattern maker, especially for wooden patterns, to properly translate the part drawing to mold